Thank you, Sumit, Anuj, Ashwani. Now, we're delighted that you could take time off this afternoon and join us here at the India Cloud Summit 21. Well, it's been an action-packed last 2 days, and security has been a theme where we have sustained our focus on. And right now, we're moving the spotlight back on this. And Rahul Sasi is connecting in on a cloud security workshop. Cloud misconfiguration and exploits. Now, Rahul is an entrepreneur, security expert, and a white hat hacker who is the founder and CTO of artificial intelligence based information security company CloudSEK. Let's listen in.
Hello, hi guys. Today we're going to talk about low-hanging cloud misconfigurations. My name is Rahul Sasi. I have almost 14 plus years of experience in cybersecurity. Been an invited speaker to almost 22 plus countries. And I'm also the chairman and founder of CloudSEK. So before we go into the cloud misconfiguration attacks, let me quickly give you an introduction to the cloud architecture at this point in time. So primarily we have two different workloads running. One is the cloud infrastructure and then applications which are running on top of it. For instance, a Microsoft web service or an Azure web service are basically a mechanism to run your computing on a virtual server. And these companies provide their virtual server as a platform for you to operate. On top of these platforms, various applications are built and deployed. For example, Freshworks runs on Amazon infrastructure, but Freshworks is a cloud SaaS software. Same, it could be one of your HR applications, which is again on the cloud as a SaaS platform. So both of these, one of them is a SaaS application, cloud SaaS application, the other is cloud infrastructure. The most common misconfigurations we see are in application layer as well as the cloud infrastructure layer. We'll go very specifically into how the AWS Amazon cloud compute infrastructure looks like, right? For example, a user who is an AWS cloud infrastructure user have various services which is available inside the network. For instance, they have the Amazon API gateway. And for instance, if you want to send n number of traffic towards an endpoint and you don't want to manage or build those endpoint, let's say you're a banking application and you receive millions of user requests every day onto a particular endpoint. If you don't want to build that endpoint, you can actually use the Amazon API gateway. So they provide a gateway API interface as a service, and you can use that to build your application on top of it. They have something like a Lambda function. They are like, if you want to, let's say you have thousands of computational operation, which is repeatedly and same in nature. Rather than doing it in one computer, you can actually trigger that operation in thousands of machines all simultaneously instead of having a server itself. And this is actually the beginning of something called serverless computing as well, right? Where you don't have a dedicated server, rather you have a job to do. You send that jobs to thousands of computers, which are all spun up dynamically. They execute the function and then return the results. Then they have something like the storage services, a DynamoDB or an Elasticsearch services, where these databases are managed by Elasticsearch, but you still have to take care of the security. You have to still take care of the DevOps part of it. You still manage a portion of it, not maybe the entire thing specifically. Then they have services like the S3, which is again Amazon's own storage server, where you have like, let's say you're storing thousands of Aadhaar cards, and you want a safe place to store it, and this is a place. And they have the cloud watch, which is basically all the a place where they can monitor all the events, etc., etc. These all come paired with the Amazon compute system or the AWS infrastructure. So you can actually leverage some of these infrastructure to build your application. Now once you build an application, you have a software which is running on Amazon cloud, so which is what we call, let's say, Freshtuck, which is why we give the example of Freshworks, right? Freshtuck is a SaaS cloud application. The application is running on the cloud, and the application uses Amazon compute system in the backend to function. So that is how the whole cloud systems are put together. Let me pick with the first, most, and the easiest to exploit open databases misconfigurations. So many of the cloud infrastructure comes with various databases for the user to choose from. So if an application developer is building a program and he wants to use Elasticsearch, he can enable Elasticsearch on his application. In fact, not just any Elasticsearch, he can actually choose from 22 plus different versions of Elasticsearch on the cloud platform. Now, the problem with these choices are that many of the older versions of Elasticsearch and MongoDB never had a default password. So any developer who choose to use an older version of MongoDB and Elasticsearch ended up exposing their databases on the internet. So what you see over here is actually an Elasticsearch which had no password, and by default Elasticsearch runs on 9200 port. And what has happened is anyone on the internet can actually check if the port is open, simply browse through the port, and he will be able to see the database indexes. Once he has got the database indexes, he will be able to browse through the rest of the data by a simple web browser. The same is actually possible with MongoDB. Because it didn't have a default password, anyone who has used MongoDB, and then if the database eventually gets the IP address of MongoDB instance is exposed online, then you would be able to connect to the database, do any sort of read or write operations. In the screenshot, what you see over here is a ransomware that has scanned the internet, looked for all the exposed MongoDB databases, then deleted actually downloaded the entire data, at least they claim to, and then deleted the data. Now the database owner has to pay 0.05 Bitcoin, a couple of $1,000 of Bitcoins, in order to retrieve the data. The other set of problems which are very common are file storage exposures. So every cloud infrastructure provides a data storage facility where it makes it easier for users or consumers of this infrastructure to store large documents without putting extra efforts. For example, S3 is a data storage of AWS. Azure buckets are the data storage of Microsoft Cloud. Now, files. Before I go into the file storage one, let me also just explain how a Firebase exploitation is very much similar to these two. In case of a Firebase, I'm going to show you an example. Every Firebase database has a URL, and followed by the firebase.com domain. Now, if the database is exposed, all you have to use is put a .json at the end of the URL, and then you will be able to see the entire database on the screen. Some of the time there'll be sensitive information. Some cases there might not be sensitive information. In this case, you can see a bunch of chat information from a random company is getting exposed, and you don't need to do even any kind of sophisticated attacks to reach here. It is simply exposed on the internet by just appending by .json to the end. Now, if you look at this part closely, every Firebase database has a ID. This is the database, or this is the UID, you can call it. This is what is used to refer this particular database. So if you want to identify all the Firebase exposed URLs on the internet, what you can do is you can just brute force these names. So for example, there might be a Firebase database with the name when you all connect, right? So you can literally brute force these names to find the bucket IDs, which is what is happening. Which is the reason I'm explaining this is in Amazon they have something called S3 buckets. S3 buckets exposure most of the time leads to the entire bucket data available. That means you put any documents on a bucket, you would be able to see all the documents in that bucket because of simple misconfigurations. So what attackers commonly do is they brute force these bucket IDs, the first octet, the first word of the bucket, in order to find the bucket IDs. In fact, there is a tool which is there on the internet, and there are many tools which you can use to find these bucket IDs, which are Lace, S3 Bucket Finder, S3 Recon, etc., who simply brute forces the bucket IDs with a large user list, word list, to find the bucket IDs. You find the bucket IDs, you would be able to list all the documents there. There is also a tool on the internet called buckets.gateware, which basically lists all the open Amazon buckets or Azure buckets or any other buckets, by the way. And for instance, if you want to show filter by buckets and see all the different, for example, this bucket which is over here, the bucket name is usp.blob.core.windows.net, has all these files exposed, right? So you can literally and some of these files, right, in some cases would be sensitive documents, and this tool basically has indexed or exposed any company bucket. For instance, you can actually search for Pizza Hut, and it will tell you all the buckets or files which has got Pizza Hut in it, and whether they are exposed to public or not, right? This would be a great tool to find these exposed buckets. Similar is the case with Azure buckets as well. Like you saw, right? You can actually go find these Azure bucket exposed Azure buckets. They become blobs, by the way, and you would be able to find them. So for example, this container is called backups. Sure, let's just go to a random bucket, by the way. We'll go to a random bucket and see if there is anything interesting. Documents, got a lot of documents, mostly files maybe, but yeah, I think you got the point. So the reason why this is happening is, by default, all these buckets, there's a configuration in the cloud infrastructure layer which you have to set. These configurations are a bit tricky, or there's a lot of documentation which is available on how to set these things properly, but by default, as always, a human mistake is what creates these bucket misconfigurations. But this, if you look at the last many news that came online, this was one of the reasons why many online storages or companies got hacked, exposed buckets. So what are some other things you should be aware about. Well, if you're using S3 or any of those blob storages, make sure the access control of these blobs are put properly. Um, there are a bunch of configurations you should be aware about. If you don't, that'll give access to your entire database to multiple people on the internet. There are multiple tools which can help you find these things. For example, bucket flows, right? It scans. You need certain set of permissions for finding this. The first set of tools I mentioned are the ones which is used to mass scan and identify buckets. If you want to specifically identify misconfigurations with the buckets in your cloud deployments, you can use bucket flows to identify them. It's a client tool, and you just have to provide them a bucket list or a list of buckets. The third and most important thing, which a category of things which we see most often, are cloud API key leakages. Cloud API key leakages commonly happen when, and this all goes back to the first diagram, right? I mean, now there are various level applications which are sitting on the cloud infrastructure, and these are applications, SaaS applications. Now each of these applications talks to each other using an API key. For example, you can integrate your HR solution into a payment application, or basically a payment application is integrated on the HR solution and via an API key, right? Now, the interesting thing is that many deployments, or many at times, there is not proper care given so that these API keys are protected properly. Most of the times they are actually hard-coded in a JavaScript file, or hard-coded in a mobile application, or hard-coded in the source code, and then the source code gets leaked, and then your key is leaked as well. So protecting your API keys are very, very important. You need to know, and I'll show you some of the API keys that kind of very often gets leaked and how they impact. And in a very great way, and once someone gets access to an API key, right, and that's what I want to show you, you can actually go to .com, and there's a bunch of examples we have put together where we show you how a leaked, for example, many people actually hard code their AWS, the infrastructure access key, inside mobile apps, or sometimes even JavaScript, like I said, right? And what happens is, it is like leaving your key in an envelope on your door. Anyone would be able to easily find the key. If they find the key, they would be able to pretty much get into their entire infrastructure. In fact, this is like an example case where the AWS key was actually, you can see it will be in this format, was hard coded inside the mobile app. This was responsibly disclosed, obviously, and because of which the entire database, in this case, this is a MySQL database which was hard coded, but in many cases the entire API key itself is hard coded, and these will actually lead to the compromises of many of these buckets. And the one way to identify is that most of the keys will start with a particular structure, or a AKI is a common structure for AWS keys, and you can always find them using some sort of regular expressions, etc., etc. Coming back, another set of problems which we see very commonly are payment keys leak. For instance, one of the things we have seen is developers hard coding the payment key. For instance, when an app is wanting to make a payment via Razorpay, for instance, the Razorpay has given out all these merchants a key. That merchant key is now hard-coded in the apps, in the source code of these apps. And the source code of these apps, mobile apps, are like public information. It's not private, right? It's like a JavaScript. You can just download an app, and then inside the app, you will see these API keys. Now, anyone who has these API keys will be able to use them and send the API key to Razorpay, and you would be able to see a ton of information. Basically, in this case, you can actually query payment information of Razorpay. You can actually even view all the transaction details in Razorpay, or in some scenarios where it's enabled, you can even do a refund. So you can actually go purchase something, and then you yourself can trigger the refund with this API key. And these are some of the data which is exposed that way. You can see all the order details, etc., etc. Based on our own research, we believe that 0.5% of apps, if they're using a Razorpay, has somehow exposed their API keys. Or you can say any startups or any company which is integrating a payment system, not just Razorpay, anyone, in that, let's say 10,000 apps, 5% of them would have exposed their keys, which will lead to one or the other critical flaw from being exploited. So those are some of the key related ones. So this is a great tool actually, where if you have a key, for example, an AWS key and a secret, you pass it to the tool will be able to identify multiple privilege escalations you can do with the key. For instance, some keys would be able to get you access to the entire infrastructure. Some keys will only be able to give you access to the PII information or whatever is possible, right? In order to find that out very specifically for AWS keys, you can pass the leaked AWS keys or whatever key you are trying to audit to this tool, and it'll give you a list of misconfigurations and privilege escalations that you can actually do. So it's mostly an enumeration script which can use to identify these threats. Just rewind on some of the issues we touched. The most common mistake which we commonly see are insecure storage access, whether it's Amazon S3 or Azure Blob. Many of them are used to store sensitive data, which they can, but then the access controls are not set that they are exposed online. The second most common mistakes which we see are secrets management, right? Your API keys primarily, or hard-coded tokens, hard-coded passwords, in multiple configurations which are deployed across. The configurations can be in an app, in a JavaScript, could be in a HTML file. It could be anywhere, which again leads to, it is a key to these infrastructures, and they end up being in the wrong hands. The third and most important one is the access to the host machines. For instance, if a MongoDB or Elasticsearch is even there without a password, the primary challenge is when it comes online onto the internet because of some misconfiguration, and the access to these hosts needs to be controlled in such a way that they are never exposed online, so that even with a weak password or wrong password, they are not in the wrong hands. Same goes to containers and virtual machines. The containers and virtual machines are like think of it like mini computers, and the communication and conversation between two different virtual machines or containers can be restricted. Access controls can be set, and a lot of things can be implemented in that layer. So giving overly amount of permissions is one problem. And the fourth is, in many of these scenarios, these organizations does not have a mechanism to log these security issues. Even when an attack is happening or has happened, the logs are not by default enabled in some computer, which will give you access to some information on the attack happened. So enabling logging and monitoring on these are very important. The fifth piece is lack of validation. You need tools that will constantly validate whether all the four are in place or not. And it cannot be a one-time or a quarterly audit, rather it has to be a continuous audit where you are constantly looking for these sort of misconfigurations and trying to optimize them, improve them, etc. etc. Overall, these are some of the higher level or very common security issues that we very often see these days. I just want to thank to Nikhil, who was been very instrumental in helping put this deck together. A lot of information was originally from his deck.